Hello, everyone. My name is Przemysław Roguski. I know that my name is really difficult, so please feel free to call me Rogue. I'm Principal Security Engineer at Red Hat, and today I would like to show a short presentation about OpenEoX project, which is related to the product lifecycle data representation in machine-readable format. I need to operate in two computers. There we go. So before we start discussing the OpenEoX project conception and objectives, we need to better understand the product lifecycle problems we have. We will start with a simple product definition itself. Then we will talk about product identification very briefly and product versioning and why it's so important for us. That will give us necessary foundation to discuss the life cycle itself. Knowing this, we will have a better understanding of the lifecycle data problems we struggle with today. And then I will show how OpenEoX can address them. At the end, we will talk about example implementation, and I'll also quickly go through today's challenges in this project. So let's start. First, let's try to answer a simple question. What does product term stand for? And I know that it may sound like a trivial question, but it's not the case. I asked this question internally at Red Hat, and I received different answers from different organizations, different teams. I was told that product is a single license. Yeah. Other team told me that product is an offering which is associated with dedicated support model. Another team told me that product is a single upstream repository that is used at Red Hat. Product. Another team told me that product is a complex product with many components, packages, dependencies, and this is the product because we build it. At the end, I heard also that product is a marketing name, is a market product name, which is a combination of many products together shipped as a one thing to the customer. So as you see, the answer depends on the person who is asked. And is it a problem? Well, it's all okay as long as we can precisely identify what we are talking about. Today, in this presentation, I will focus on software products. Let's move to the next slide. So in regards to the software products, product identification in the industry, we have many approaches how product can be identified. We can use CPEs, everyone knows it very well. We can use PURLs, package URLs, usually used for Git repositories, but we can also use software identification tags, software heritage IDs, and there are many more options. Today, I don't want to spend too much time on the software identification because tomorrow, my good friend Martin has a dedicated session about this topic. Today, I would like to focus more on product versioning and why it's so important for us. So in the software management, you will very fast understand that you need precise versioning that will allow you to distinguish changes in your software code. Version logs the state of the software in the particular point of time. That includes also all correlated requirements and dependencies for this software. So this is one version. And if you want to include some update, then you need to release a new version of that software that will again log the code of your application in a particular point of time on the time of the release, and again, all correlated dependencies. At Red Hat, we follow XYZ semantic versioning, where X refers to the major versions of the product, and each major version changes in all of those in each major versions are not backward compatible, and many times update from one major version to another one is not that simple. Why? Refers to the minor versions, also called product streams. Updates that goes to the Y streams are backward compatible. And at Red Hat use case, many times one product has many multiple Y streams supported at the same time. Z refers to the asynchronous updates, patches that are released as a part of the specific one Y stream. Let's take a look at the real example. Red Hat OpenShift Container Platform 4.18.5. In this case, 4 represents the major version of the OpenShift Container Platform product. 18 is a supported stream, and 5 is the 5th update as a part of 4.18 stream. Stream itself, as a supported the product version, is associated with unique CP IDs. On this slide, you see official 2 CPs assigned to OpenShift 4.18 stream. So we just briefly discuss what product term can mean and how we should use product versioning. That gives us necessary foundation to discuss the product lifecycle. On this slide, intentionally, I included a full lifecycle definition that is used in the OpenEoX project. In short, lifecycle is a combination of product versioning and associated with this version product support model, where support model is defined by vendor or owner of that product, set of maintenance rules starting from the release of the product, GA date, until the end of life. And the maintenance scope can change over the time, starting again from GA to the end of life for the particular product or single product stream, product version, like we just discussed in the previous slide. We can distinguish many different support scopes, which define the lifecycle phases for that particular product or product version and associated point of time in the product life. In this slide, I included an sample of possible lifecycle phases. So we can have, for example, maintenance support phase, which is identified by end of maintenance support type. But we can also have end of vulnerability support, end of migration support, and many, many more defined by the vendor or owner of the particular product or component. And those lifecycle phases can be handled in a different way. We can distinguish 2 approaches. One is situation where the phases, lifecycle phases, are connected together in a like a chain, which is called consecutive phases, where end of one phase is a beginning of another lifecycle phase, like it is visible on this very, very simple diagram. Another option is overlapping phases, where, as you can see, maintenance support phase 1 and maintenance support phase 2, the start date is exactly the same, but the end dates of those 2 support phases are different. So to summarize, product term can mean many things. Product versioning is very important and is associated with the product lifecycle, where in the product lifecycle, there can be many phases with different scopes and different end dates. It can be very complex in many cases, isn't it? And the biggest problem is that today, lifecycle data are available mostly in a human-readable formats. It is also important to mention right now that we can have a situation where we have 2 vendors that offer 2 products. Those products could be very similar, could even use exactly the same sources, have the same functionality, but there are two different life cycles depending on the vendor decision. There could be situation where one product is supported for a longer time, but with very limited support scope, when another product distributed by another vendor has very short support life cycle, but with very big scope. In this case, we have also a situation where owner of a single component, where from that owner perspective, that single component like a Git repository is a product, is already end of life. It's not supported by the maintainer, but it's still supported by the other vendor who just used this component as a part of his product, right? And here we have OpenEoX project, where the main intention is to allow exchanging the lifecycle data in the standardized machine-readable format. First intention when we start working on the OpenEoX project was to cover only end of life and end of support maintenance phases, but very fast we realized that there are many more use cases which require data about different lifecycle phases. We want to make sure that OpenEoX will work together, will be compatible with other security data like SBOMs or CISA VEX data, which will allow customers, users, members of teams like security, support, compliance teams, product planning, management, including also sales and marketing teams, that will allow those all users easily accessible way to get product lifecycle information. That product lifecycle data gathering is fast and can be done in an automated way. Here is a slide where I wanted to present how OpenEoX can work together with SBOM, VEX, and CISA data. In this case, user who, for example, take an SBOM for one particular product, see the content of that product, can verify and check the security statement based on the produced by the same vendor, VEX and CISA data, and at the same time can very easily check the product lifecycle based on OpenEoX data produced by exactly the same vendor by using the connection. In this case, the connection is through CPEs and pools. So user can check that, okay, this is my product, this is the content, and this is the existing current phase for this product. I know how long this phase will remain and how long this product will be supported. Let's take a look at real example. So here is a Red Hat OpenShift Container Platform lifecycle. This is a screenshot from our public webpage. You can check it. As you can see right now, we support 6 different streams at the same time. Every stream is right now in a different support level, different phase with different end dates. So it's really complex for the end user to collect information in an easy, automated way. What is the current state for the particular one of those streams at this point of time? But in OpenEoX, we can represent this lifecycle in a very easy and precise way. This is an example. I didn't use any specific format. It's just an example how the data could be structured and what are the most important pieces here. So we have a product identified associated with dedicated UID. We have product type, which is information, what exactly it is. In this case, it's a cloud product. Business unit, something that is important for Red Hat, is like a cloud computing. Information about the parent product, in this case, Red Hat Enterprise Linux. Every product must have associated all phases that are used in this particular product. I will show it in the next slide. Now we have all versions that exist for this product. In every single version is identified by CPE ID, like I was presenting in the previous slides. And we can quickly check what was the previous version, what is the next version, what is current phase right now at this moment. As you can see, right now, version 4.12 is in a phase number 4, which is represented by end of extended support OpenEoX type, and associated date, it's January 2026. Like I said, every product has list of all phases, and those phases has precise information what is included in the particular phase, what rules are associated with that phase. On this slide, I only included the first 2 phases. The phase number 1, which is the GA date for this product, and then we have phase number 2, represented by the end of full support type, which is the full support phase, and we have precise scope. And in this case, it's not exactly what is in the official OpenShift container platform support model, but I included that in theory you can use a scope and define as a multiple selection array where you have new features, bug fixes. Intentionally, I brought here that security patches could be distinguished based on the CV severity level as well. So every vendor can specify that, for example, in this product, in this version, and this point of time, I will only release critical security updates, nothing else. So it will be very precisely identify what customer can expect from this specific version at this point of time. What we have today in regards to challenges in the OpenEoX project itself, and what are the challenges at Red Hat side. So on the OpenEoX project itself, we're working right now on the universal taxonomy that will meet all possible project users requirements. We have ongoing discussion if it would be better to have a single scope as an identification of the phase, or maybe it would be better to have less phases, more on the more granular level, but the scope will identify what exactly is included in that specific phase. We also had a discussion about if we want to use date ranges, or maybe one single date will be enough. At Red Hat, we are discussing right now how to use this data standard across all organizations. We also have ongoing discussion about the scope of customization, because not all data that we need internally at Red Hat should go outside, should be public. So it's a discussion about the difference between internal and external data. And at the end, I would like to just summarize why we need this type of information. Today, almost everyone can create SBOM for a product, right? Then we have a lot of options how we want to show security posture for the particular product. So we have SBOMs, we have already CISA VEX files, OpenVEX, and so on. But the biggest problem is that still, we don't know what we're talking about. I can create an SBOM for one container image. My friend can create another SBOM. And yeah, we can assign some CVEs, we can publish VEX files, but we don't know what exactly it is. Is it a single Git repository, or this is a product? If it's a product, what is included in that product? So from the end user perspective, what exactly is the single source of truth here? Is it my SBOM and someone else VEX, or maybe someone else can prepare SBOM for my product? Where is the truth? If we use OpenEoX and we publish next to the SBOM, this is the product, this is the type, this is the who is the vendor, this is the product lifecycle, and this is what is promised as a part of this lifecycle, that will be very clear and give us clear picture where we are and what we're talking about. So that's it from my side for today. Thank you very much. And now we have a couple of minutes for our questions.
We have just a few minutes. I'll start over here.
Good morning. This is John
Hi, John.
Kavanaugh. So when you speak of end of life, Does that mean if it's a proprietary product, if I continue still to use it, am I now violating your license with me because you're no longer selling it?
Well, I wouldn't say that it is a license violation because I will just, as an owner of this product, I promise you to deliver some type of support, and this is the end of life. You know, at that time, there's no more support from my side. If you want to continue using it, of course, okay.
But I can't maintain it because it's your product.
Well, we can use it.
Okay, at my risk. Okay, thank you.
Yeah.
Oh. We're gonna just wait for the next one.
So, just a second.
It's my turn to talk, Marina. So, Rogue, thank you for sharing this today. Is one of the challenges, or that might have been grammatically awful, I don't know, is one of the challenges you're seeing, where do we source this lifecycle data from? Is it a human inputting this data? And if so, it's only as good as the process and humans maintaining it. And then also, how do you account for those situations where some products like to say support starts at, you know, their release plus 3 months or something like that? So just kind of curious if you've discussed those challenges.
Yeah, so this is related to the backend implementation, how it will store it on our side, like, you know, on internally at Red Hat. We can have a connection between two phases. Let me show it in the slide. There we go. So we can have a connection between phases, and we can specify that, for example, the next phase end of date is phase number, like for example, phase number 4. The end date is phase number 3 plus X days. That will represent that we have today in the human readable format. Oh, okay. It's not the case in regards to the OpenShift container platform, but we have already products at Red Hat where the lifecycle is specified date plus X months, or for example, next release, next version plus X months or days. But the same can be represented in the OpenEoX standard by joining specific phases and adding that the end of previous phase plus X days or months is the date end of the next phase. Yeah, you need someone who owns the life cycle for that for the product to decide when there is going to be a next release, next version, or for example, when and how long that product is going to be supported. We can add a lot of validations that make sure that there are no, for example, mixing information that the next phase end is before the previous one. So there must be validation of the data, but at the end it will be an owner of the product who will specify what is the life cycle. Marina.
I have a very basic question because I missed the beginning. So OpenEoX is a new standard that you're working on?
Yes.
What does EOX stands for?
At the beginning, we wanted only to cover end of life and end of support, but that's why we created that OpenEoX term.
So I think I'm just going to follow on with what you just sort of said is that in the beginning we had a certain thing that we were working towards. From what I'm hearing, we're complexing it and making it a little bigger than what we need maybe from the start. Have we thought of phasing our approach here so that we could just have some of the basics? I understand trying to figure out how to tie it in the SBOM and VEX and all that, but I feel like we need to get the industry to agree to at least the original stuff. So what are we doing to at least get somewhere?
That's a very good question. Yes, we cannot address all problems in one shot, in one release. So definitely we need implementation phases. And right now there's ongoing discussion, what is the minimum for this project to just start it, make sure that people will use it, and then adjust it over the time based on the customer needs. So right now we want to make sure that we can support the most typical use cases, which is G8, end of life, end of specific phase, and that's it. Yes.
I was curious your thoughts on both uncooperative vendors or just maybe being more generous, ignorant vendors, and helping them along, because obviously this sort of thing that needs there's a big hurdle in the beginning in order to be useful, and if you're relying on vendors to do it, it's going to be very difficult to get enough momentum to make it tremendously useful. But if you had some sort of taxonomy in there for community supported, or this is being maintained by this person who doesn't actually work for the company but likes to read their website or something like that, might be helpful.
Yeah, that's very true that at the beginning, the implementation will take a long time and will be very problematic. But like I said, today we have really big data problem. Now, everyone talks about S-bombs, but even if you compare two S-bombs, it's really difficult to say what exactly it is. I see that list of the content, nice, but what exactly it is?
And S-bombs have really gained momentum from both government pushing on it and, for better or worse, insurance companies pushing on, customers pushing on it. So yeah, if you can get that same sort of momentum, it'd be an excellent way to work.
Yeah, I agree. And I really believe that OpenEoX can help, clean a little bit the current problems.
Any guesses or any way to know what the level of adoption is, number of packages or projects?
It's too early yet.
Okay, like order of 10, 100,000?
What do you mean? Sorry.
How widespread is the adoption? How much? EOX, how many projects have adopted?
How many projects? Okay. Well, again, right now it's too early. Right now at Red Hat, even at Red Hat, we're in a very early stage where we're just discussing how to do it and how to publish to customers. So right now it's too early. We cannot, we don't know who exactly can use it today.
Hello. Hi, this is Mayurish. One question. We just implemented CSAF that was introduced by Red Hat recently. So why are we working on two different standards when we can leverage the same standard? Because CSAF is again security related. This is EOL again. You can talk about it in security terms. So why not just make two different?
Well, very good question. And the problem is that the scope is different. Like I was presenting in one of the slides, product lifecycle could be very complex. And you need to know what is available today for this particular product version. And it's impossible to put all of those things to one standard and create a giant metadata information. It's impossible. And changes in the CISA files are more dynamic, where the life cycle is more stable.
I know there's a couple other questions in the room. I encourage you to put the questions into Discord. At this point, we are out of time. Let's give a big round of applause to Rogue.